Hello, everyone. Welcome specially to the Engineer Construction Lecture Hub. This is a platform where updates as regards to construction is rolled out, as progressively. So today I want to discuss on a topic I titled "How to Maintain or How to Prevent the Formation of Honeycombs in Our Concrete." Now, formation of honeycomb is prevalent in construction these days. All right, there are some factors that brings about that formation of honeycombs in our concrete. So today we want to look at uh, those practice, okay, that usually lead to the formation of honeycomb. But I want you to understand that honeycomb is usually regarded as a formation, all right, of voids, openings on a concrete surface. All right, that is what we refer to as honeycomb. So usually honeycombs are formed when concrete is not maintaining good quality. Okay, we can experience formation of honeycomb because honeycomb uh, could be as a result of wrong placement of our concrete. So we want to discuss extensively on some of those measures, okay, how to prevent these formation of honeycombs. All right. But before we go into the measures, let's discuss on the causes so we can have it in mind whenever we are dealing with our concrete. But before we go into that, I want you to understand that concrete is a material that attention should be paid critically to. All right, because the concrete is meant to be a coverage to our reinforcement, to the rebars. All right, now if peradventure this concrete have spaces, okay, now these spaces will not expose the reinforcement, and once these reinforcements are exposed, they are vulnerable to rusting, to corrosion, because our steel, once water comes in contact with it, once water comes in contact with it, and the presence of air, definitely corrosion will come into play. All right, and when that reinforcement corrodes, definitely the diameter of that reinforcement will also depreciate. All right, there will be reduction, gradual reduction in the diameter, and that will affect the tensile strength, because the tensile strength of a reinforcement is also a factor of the diameter of that reinforcement. All right, the reason why I said it's a function of the diameter is that when you have the same strength of steel but of different diameter of bars, you see that the higher diameter will possess more strength than the lower one, irrespective of having the same tensile strengths, characteristic strengths. Okay, so we must have that in mind. So it's important that we don't neglect this aspect of honeycomb, because most times you see that when we do our concrete, we once it's wrongly placed and there is formation of honeycomb, you see that we tend to use mortar to fill those spaces. Especially there are some cases where the reinforcement will be literally exposed. Okay, concrete that is supposed to guide the reinforcement, there will be absence of concrete in some part of that structural component. All right, now when you use your mortar to fill up those spaces, I want you to understand that the mortar does not possess the same strength with the original concrete that is used or that was used for that structural element. All right, so it's important that we try as much as possible to avoid the formation of honeycombs in our structural element. That is also a way we can enhance the performance of our structure. So let us look at some of those lapses, okay, that could lead to the formation of honeycombs in our concrete. Okay, so first and foremost, we'll look at a situation where we have improper mixing of concrete. Improper mixing of concrete can lead to the formation of honeycomb. Now, as you know, concrete are being proportioned. Concrete is a composite material in the sense that it comprises of your cement, your sand, your granite, and your water. These are different materials that are brought together. So you must ensure that they are thoroughly mixed. Okay, once they are thoroughly mixed and they are homogeneous, it means that the tendency of honeycomb formation will be minimized. All right, there are other factors that will come to play that will further enhance the total elimination of honeycombs in our concrete. Okay, so we try as much as possible to look at the area of improper mixing of our concrete. For us to prevent the formation of honeycombs in our concrete, we must mix our concrete very well. All right, so that is one of the ways one of the improper mixing of concrete is one of the causes of honeycomb. Then we also have improper aggregate grading. Okay, improper aggregate grading. Now you know that aggregates have distribution. All right, they have distribution, and when we talk about grading, we are looking at well graded concrete. Well graded concrete. When you have a well graded concrete, a well graded aggregate, sorry, when you have a well graded aggregate, it shows that there is a distribution of sizes of these aggregates, from the least to the maximum size of that aggregate. All right, for example, if you're looking at 20 mm size of aggregate, okay, it means that if that 20 mm aggregate is well graded, it means that in that mass, in that size of aggregate, you have lesser sizes of aggregate that are below 20 in that composition or in that grading of that aggregate. Okay, so when you have that distribution of various sizes that are lower than the maximum size, okay, it means that that aggregate is well graded. Okay, so we must take note of that. Then in the area of our sand too, we must ensure that the distribution of our sand, okay, the sand, we have the coarse aspect of our sand, we have the fine aspect of our sand, because as you know, sand acts as a filler in our concrete. So it is important that the distribution of this this sand should be between the fine and the coarse. And usually the coarse is usually 4.75 millimeter. That is the maximum size of the coarse sand. All right. So we must maintain a well-graded aggregate for our concrete. Now, when you maintain this, what it means is that these aggregates, the distribution of these aggregates, showing that they are well-graded, will help to fill up all the voids. There will be this interlocking of the various aggregates, all right, because what the cement does is that it initiates or brings about the binding effect. Now, what enforces that binding or that bonding, okay, apart from the cement, is the aggregate, because the aggregate is what sustains that concrete mass. All right, so we should try as much as possible to use well-graded aggregates for our concrete production. So if there are a kind of situation we have improper aggregate grading, definitely it will lead to the formation of honeycomb. Now, let me also give an instance. There are some situations where we have a non-uniform distribution of aggregate, where you have a particular size, okay, dominating, that is more okay, is in excess, uniform size of aggregate in excess, what it means is that there won't be smaller sizes of aggregate that will help to, create that connection within the concrete mass. All right, because all of these distribution have their own role to play within the concrete mass. So for us to maintain or to prevent honeycomb formation, we must avoid improper aggregates. We must ensure that our aggregates are well graded. All right, they are well graded in the sense that they have good distribution. All right, so that, because once there is no distribution, you see that the areas where you have smaller sizes of aggregates to fill up due to the absence of those aggregates, definitely there will be openings that will be created. There will be voids. Okay, there will be voids, there will be pore spaces, all right, within that concrete mass, and that will make the reinforcement or the steel bars to be vulnerable, to corrosion. All right, so the essence of our concrete, one of it is to protect our reinforcement. We protect our reinforcement against corrosion, against heat, as a result of fire and all of that. So it's more or less a protective medium, that is concrete. So whatever material that we are using for our concrete, we must ensure that we do our mixing thoroughly. Our mixing should be done properly. We should also ensure that we use well graded aggregates for our concrete. All right, so you take note of that. Then we'll also look at congestion of reinforcement. All right, congestion of reinforcement can also lead to formation of honeycomb in our concrete. Now you see that concrete basically plays a function of coverage to our reinforcement. Now most times you see that due to maybe the design or what is provided, you see the spacings of probably the stirrups and the reinforcement are very close. Okay, they are very close. The spaces are even less than the size of the maximum size of aggregate that is intended to be used for that component. Now you discover that when that happens, you see that there are some aggregates that will be trapped. Okay, because for example, if you have a depth that you need concrete to be filled up, okay, now when you introduce your concrete is expected to move down to the bottom and fill from the bottom to the top. Now in most cases, when you have larger size of aggregate that are bigger, okay, than the spacings of our reinforcement, okay, you see that those aggregates will tend to be trapped at the top. Now when they are trapped at the top, while pouring the concrete, you think that the concrete has gone down. Even when you have applied vibrations and all of that, you think that the concrete have gone, as in the concrete have all moved down, without knowing that there are some aggregates, some coarse aggregates, granites, bigger sizes of granite that tend to, a kind of obstruct that pathway. Okay, those spaces that the concrete need to move through, those large size of aggregate tend to block them. And when that happens, without your notice, you see that after the placement and the hardening of that concrete, you see that spaces will be created internally. Okay, these spaces is as a result of those bigger sizes of aggregate that obstructed the pathways, okay, which is as a result of congestion of reinforcement. When you have more of reinforcement in a structural element and they are very close in terms of spacings, you see that the tendency of formation of honeycomb will be there. Okay, it will be there because this concrete is supposed to surround the reinforcement. All right, concretes are meant to surround the reinforcement and create that bonding, okay, between the concrete and the reinforcement. All right, so but most times you see that due to congestion of reinforcement in our formworks, you see the concrete, the stones, bigger stones tend to create obstruction, in during placement of the concrete, and that usually leads to the formation of honeycomb. So I want you to have that in mind, that congestion of reinforcement, okay, in our formworks usually leads to the formation of honeycombs. Okay, so have that in mind. If you're just joining us, we are discussing how to prevent the formation of honeycombs in our concrete. All right, so we've talked about some of the causes. All right, so another one we are going to look at is delay in concrete placement. Delay in concrete placement. Now, concrete is expected to be placed at once. Okay, they are supposed to be placed at once. Concrete that maintains homogeneity is expected to be placed at once. Now, if there are break in placement of this concrete, okay, it can lead to the formation of honeycombs. Now, let me give you, for example, you see, if you're doing a manual mixing of concrete, you see that there are different points, okay, except you're using a concrete mixer. But if you're doing I'm just giving an instance in a situation where there is the mode of mixing of concrete is manual. All right, now you see that they have different spots where they have their mixing areas. Okay, you see that when Mr. A brings his concrete and pour, Mr. B brings, due to the different variations in the mix, and as well as in terms of the placement is not, the concrete is not homogeneous. All right, during placement, it means that there are breaks, there are time lapses, okay, during placement. That could also lead to the formation of honeycombs. Now, honeycomb is a kind of comes to play as a result of some of these factors that we are discussing today, okay, which we must have all of this in view when we are carrying out our construction, so that we can prevent the formation of honeycombs. Honeycombs looks like something that attention should not be paid, which are usually neglected, more or at sight. All right, but we must ensure that our concrete is devoid of formation of honeycombs. All right, the original concrete should entirely cover reinforcement, so that it can give it that protective coverage that it requires. Because once there are formation of honeycombs on our concrete, it means that concrete has the performance of that concrete has also been affected, okay, in the area of coverage. It's expected to protect the reinforcement, not to allow the reinforcement to be vulnerable, to corrosion. All right, so we must ensure that we prevent formation of honeycombs. All right, so thank you so much. I appreciate every one of you online. If you're just joining us, we are discussing how to prevent the formation of honeycombs in our concrete. Now, like I said, when you have honeycombs in your concrete, it makes the reinforcement to be vulnerable, all right, to corrosion. All right, and the reinforcement will not have adequate protective coverage, okay, that will enhance its longevity. All right, because once your reinforcement undergoes corrosion, automatically that reinforcement tensile strength will also be affected, because the diameter will also reduce. Then there are other defects that will come to play, like your spalling, okay, delamination and all of that. These are defects associated to concrete and reinforcement. All right, so it's important that we ensure that these causes are looked into when we are dealing with our concrete, so that we can prevent the formation of honeycomb. All right, our concrete is expected to be totally impermeable. All right, impermeable. Water should not even penetrate at the end of the day, because you're trying to protect the reinforcement. All right, there are some cases we have our reinforcement being exposed as a result of these honeycombs on our concrete. All right, so another cause that another area that usually leads to the formation of honeycombs is bad formwork. Bad formwork. Now, formworks could be wooden material, it could be steel, it could also be plastic material, okay, that is used for that concrete, all right, for the structural element. All right, now it's expected that this formwork should have total coverage of the reinforcement as well as the concrete, and also carry the weight. Then this formwork should be tight enough. There should not be openings or leakages, because once you introduce your concrete, all right, now the water that is used for that concrete production ought to enforce hydration in that concrete. Now, the enforcement of hydration in that concrete, it's what brings about the gaining of strength that concrete ought to have. The development of the strength of that concrete is dependent on the hydration of that concrete. And hydration is a function of water. Okay, it is the water that brings about, activates the hydration process. Okay, between it's a function of the cement and water. All right, so immediately you introduce water, hydration has started. Okay, so now when you place your concrete in that formwork, it's expected that your formwork should be devoid of openings, okay, that will bring about leakages. Now, when there are leakages, you discover that the water tends to escape through those leakages. Water tends to exit, okay, through those leakages. Now, remember, it is that water that brings about the fluidity of that concrete, is what brings about the lubrication of that concrete. Now, if that water, exits from the formwork, it means that it will be left with more of the aggregates. All right, it will be left with more of the aggregates in that formwork. Now, in the areas where that exit of water within the formwork takes place, that is where honeycomb will be formed. Okay, there will be formation of honeycomb around that area, because as that water leaves the concrete, it's creating openings. Okay, it's creating openings. It is supposed to create that closing of those spaces. All right, but by the time you have leakages in your formwork and the water tends to exit through those openings, you see that it will lead to formation of honeycombs. So it's important that we inspect our formworks thoroughly. We ensure that they are rigid enough, that they are tight, the spaces are tight, all right, the bracings are done properly, all right, where there are joinings, okay, you must ensure that those joinings are firm enough, all right, that they will prevent those exit points for the water in our concrete. All right, because once although it can be limited, to an extent, but if it's excessive, that is where that honeycomb formation will be formed. All right, so let's have that in mind. So please, if there is any question as regards to what the topic of discourse, you can drop them at the comment section, and it will also be attended to. All right, so still on the causes of formation of honeycomb, we also have a situation where we have insufficient vibration and compaction. All right, this can also lead to formation of honeycombs in our concrete. Now let me differentiate some of these areas. Okay, now when you come to our structural components, the beams, okay, the beams, we can adopt vibration. All right, we can adopt vibration for our beams. Now our slabs, we can adopt compaction. Okay, even the oversight for our German floor, we can also do compaction. All right, the difference here now is the depth. Okay, because when you have higher depth, it will need thorough vibration to ensure that the cross-sectional area of that structural component are all, all the spaces are, closed up, and that concrete is densified. All right. Now, in the case of a slab or an oversight concrete flooring, all right, is compaction. All right, you do compaction. You can use your flute, you can use your rammer, you can use all of those tools to carry out that exercise. So, but be it as it may, any of these aspects, you must ensure that you do them thoroughly. Now, if you don't, that will bring about the formation of honeycomb. Okay, we should ensure that we do our vibration where necessary. All right, then we also don't do it excessively. We don't do it excessively. That is why in some cases we introduce some hard mixtures in our concrete. There are hard mixtures that brings about high workability and still give higher strength of concrete. Now, when you use such hard mixtures, you don't need much compaction. All right, for example, in your slab, in your decking, if you're doing your decking and you introduce such hard mixtures, you see that the messing guy that is working on that concrete will be doing it at ease without any stress. Because once you pour the concrete, once you place the concrete, due to the hard mixture present in that concrete, the concrete will take its shape. Okay, it will take its shape. Now, a little application of waves or compaction will just give that concrete the required. It will be like a self-compacting concrete. All right, it will be like a self-compacting concrete that doesn't require more of those compaction on its own. It can occupy that designated space that is meant for that particular component. All right, so we must ensure that our formworks are not faulty, they are good formwork. We must also ensure that compaction, we administer sufficient compaction to our concrete, and also vibration as well. All right, then also we must look at areas that are ideal for a particular mode of placing that concrete, giving that concrete the required density that it needs. All right, so it's very, very important. Then also the area of poor workability of concrete is also another aspect that brings about the formation of honeycomb. Okay, poor workability of concrete. Now, I talked briefly about it in the previous point that I raised, but let me still emphasize on it. Now, when you talk about workability basically is the ease at which concrete can be worked upon. All right, now this concrete needs to maintain certain level of fluidity. All right, it should be plastic. You're plastic in nature. All right, now when we look at the homogeneity of a concrete, that homogeneity is a function of the strength as well as the workability. These are the two parameters that we can use to judge or a kind of evaluate the homogeneity of a concrete. Now, workability makes that concrete to be easy to be placed. Okay, it creates that ease at which the concrete will be placed. Now, when that concrete is placed, without any form of being stiff, all right, there won't be any formation of honeycomb. But a situation whereby you have a lean concrete, a concrete that is not that have low fluidity, all right, you see that concrete will definitely, there will be formation of honeycomb. That is why in some cases where you're doing your concreting for your columns, okay, when you're doing the concreting for your columns, you see that for columns you need good workability, concrete that are of good workability, all right, so that as you're pouring in that concrete, the concrete will on its own, try to adjust itself by filling up all spaces within the formwork, all right. And when that happens, you see that you just need less vibration for that column, all right, or a little tap on the formwork. You see that the spacings will be covered properly, all right. But a situation whereby you adopt a concrete of low workability, okay, a concrete of low workability, you see that column having formations of honeycombs, along that height of the columns, all right. You see formation of honeycomb, which is not good for that column, because columns are axial members, all right. It is column that directs the load to the foundation. So we must give every protection that is needed for our columns, all right, so that our columns can be able to perform optimally. So like I said, poor workability of concrete can result to the formation of honeycombs, all right. So we must pay attention. We shouldn't neglect this honeycomb, because most times you see that when we do our concreting and after removing of formwork, we start seeing openings around our structural elements, your columns, your beams, and all of that. You start seeing the stones, exposed. You see the reinforcement exposed. It is not good. It's not a good practice, all right. Those reinforcements are not supposed to be exposed. They are not supposed to be exposed. And remember, when they are exposed and you try to use mortar, okay, you try to use mortar to cover up those spaces, remember that the mortar you use doesn't have the same strength with the original concrete. So there is still some lapses, okay, that will come to play, all right, because the concrete has some level of impermeability, all right. It has some level of impermeability, your concrete, okay. Once you have a quality concrete, it has some level of impermeability, all right. But your mortar now does not have that in terms of strength, and also that impermeability, that level of impermeability. So there will still be the difference. There will still be difference, within that structural element. And that most times when there are stresses, okay, the stresses tend to go towards those areas that are weak within our structural component, all right. Although the formation of honeycomb is more or less on the surface of our concrete, all right. Basically, for us to avoid this honeycomb formation, or the essence of avoiding this honeycomb formation, is basically to protect our reinforcement. Basically to protect our reinforcement, and also to give our reinforcement the needed guide to be able to perform its function, okay, based on its position within the structure, all right. So it's important we have that in mind. Then I also want to look at improper placement of concrete, which I've also highlighted in the previous point that I talked about. Now, when you have improper placement of concrete, can also lead to the formation of honeycombs in our concrete. Now, concrete are expected to be placed in a certain manner. All right. Now, when you do it on the contrary, you see that definitely honeycomb will be formed. All right, because you're dealing with materials. Is a material that is made up of different materials. All right, concrete is made up of different materials. Now, these materials are supposed to be placed rightly so that each of these individual material that constitutes concrete can be able to perform its function. Because as you know, in a concrete mass, we have the cement, we have the fine aggregate, which is the sand, we have the coarse aggregate, which is granite, we have water. Now, these are the okay, you're welcome back. Sorry for the abrupt disconnection. Welcome back. So, like I said, your concrete is made up of your cement, sand, aggregate, and water. Now, the cement in that concrete acts as a binder. All right, it acts as a binder. Now, the sand in the concrete acts as a filler. Okay, it is the sand that fills those spaces within the concrete, okay, that gives it that good finishings. All right, so that is the function of the sand. It acts as a the aggregate, the coarse aggregate, in this case, the granite acts as what provides the density for our concrete, is what gives the weight, and also what gives that effect, that interlocking effect within our concrete mass. So that is what the coarse aggregate, the granite, the chippings does in our concrete mass. Then the water in this regard is what facilitates the hydration process. Okay, it is what activates the cement, okay, for the chemical reaction to take place. Okay, because you know the cement is reactive. So it is water that initiates that reaction to begin. Okay, and also that the same water is what brings about the hardening of that concrete. So that is why water plays a very important role during production and also after that is post concreting of structural element. Now the post concreting now in this case is the curing aspect. Now our concrete ought to be cured, after 24 hours. All right, it's important that we cure our concrete. That will bring about the continuous hydration, because that hydration is what brings the strength, the strength gain. Look at it in this perspective. So all of these are the causes or the lapses that could bring about the formation of honeycomb. All right, you're welcome. I appreciate you all. Please, if there are questions, comments, you can also drop them. All right, so we are discussing how to ensure to maintain good homogeneity of our concrete, so that at the end of the day we will not have this formation of honeycomb, because our reinforcement should be protected. All right, they should be protected so that they can be able to last long, they can be able to perform optimally. Now there is another thing I want us to understand. Most times you see that in our structure, especially buildings where you have your lintel chaining, okay, where you have your lintel chaining, you have a lintel beam that runs all through the walls of that building, both external and internal. Now, as time goes on, during the servicing or the serviceability aspect of that structure, you see that once you bang the door, there will be a resonance on the windows. All right, there will be a resonating effect on the windows. Now, this could also be attributed to formation of honeycombs. Now, there are some honeycombs that are internal. Okay, there are honeycombs that are internal. Honeycomb is basically having spaces, creation of spaces within our concrete mass. What we've talked about all this while is more or less the surface. Okay, but there are some formation, internal spaces that are created within our concrete mass. Probably will think that all is well once the entire surface is covered, the entire surface of that structural element is covered. Okay, we'll think that all is well, but most cases you see that internally there are spaces that are created within those beams. Okay, in most cases you have those cases in beams. All right, now you see that as a result of those spaces that are created, when you bang your door, when you close your door, forcefully, you see that that effect will travel, will generate a wave, okay, that will travel through those beams, and due to that spaces within that concrete, that beam, it will cause a resonating effect on the openings, your windows, and you see your window vibrating. Okay, after you have banged the door, okay, you notice that your window, the GMP, okay, you have your window will vibrate a little. Okay, this is as a result of those spaces created within the structural element. All right, so that is why in most cases when we want to do tests, we want to carry out tests on these various structural elements by carrying out a non-destructive test. Okay, there are some cases we do ultrasonic sound test, ultrasonic wave, or rather test, that usually waves are induced into structural element. Now when these waves are introduced in the course of testing the integrity of that structural element, you see that waves will be introduced into that structural element. Now what that wave will do is that the wave will travel into that medium and try to locate those spaces within that concrete, okay, and now bring back a response. Okay, that is what judges how that structural component is. Okay, so that is why it's important we do thorough vibration. We try to eliminate any form of spaces internally, of our concrete structures, because all of these have their own effect on the functionality of that structure. All right, so it's important we take note of these causes of honeycomb formation in our concrete. Now, most cases, like I said previously, when you cover those exposed reinforcements with your mortar, with time, you see that there will be a kind of there will be a disconnection, a detachment, okay, that will take place around those areas where you use your mortar to cover the reinforcement. The reason is that those mortar does not possess the same strength of concrete, the original concrete that was used for that structural element. Okay, so but this can be avoided from the beginning. So that is why construction is a very meticulous activity. Okay, we shouldn't neglect any aspect of it. We shouldn't neglect, because most times some of the defects that we have in our structures are as a result of construction errors. They are as a result of lapses, that are ignored during the construction stage of that structure. All right, so let us look out on these various causes that I've talked about. All right, and try to carry out our construction rightly, by avoiding these factors or these causes of formation of honeycomb that I talked about, so that at the end of the day we can have a sound structure. Okay, that is the primary objective. And also we should pay attention to details. Okay, we should pay attention to details. We shouldn't neglect any aspect in our construction, because most times you see that any aspect that is neglected, or you encounter error and didn't attend to it at that point, it have a way of being carried over. Okay, because construction is done in stages. There are different stages in construction. In building construction, there are different stages. Now all of these stages have their various challenges and all of that, so it's important that we address them at every stages. We shouldn't ignore those lapses at a particular stage. Okay, it has a way of manifesting during the lifespan of that structure. All right, and that will have a negative impression about your construction expertise, and also your integrity as a professional, because it is wrong for you to put a structure that will malfunction when your client start using it, because at that point it is your client that bears the brunt, okay, of those errors. All right, so it's your client that bears those brunt. So it's important that we do the right thing at the right time. All right, so that at the end of the day they will have the true satisfaction of having that structure. Because most times you see that during the lifespan of that structure, a lot of defects will start manifesting. Okay, it will start manifesting, and at that point you see that repairs will even cost more, especially these days that the materials are very expensive. All right, let us endeavor to carry out this practice rightly. We should utilize these materials rightly. We should do it in line with the standards, so that at the end of the day you have a good name to protect. Very, very important. Okay, it's not all about the money. Okay, it's not all about the money. The most important thing is having a good name attached to that structure. Let your client not in one day feel regret of having you giving you that job, because whether you like it or not, there are a lot of clients today that are pained as a result of some of the lapses in our structures. They are pained, and it's not supposed to be so. When the right things are done, you will see that they won't have any cause to feel regrets or feel inconvenient, okay, in their own structure. So basically this today's lecture is centered on that awareness, for us to know some of the causes or those lapses that can lead to the formation of honeycomb. And honeycomb, when you have honeycomb, it has direct impact on our reinforcement. All right, because it is the reinforcement. For example, when you look at the arrangement of our structure, the slab is hinged to the beams are hinged to the columns. All right, the columns goes to the foundation. Now this is a pathway. Okay, this is a pathway of load transfer. Now there shouldn't be any situation where any of these structural elements is suffering. Okay, there shouldn't be any aspect of this structural element that are defective, because once you have any defective element, it will bring it will try to truncate that transfer, and that will bring about structural failure. And when you have structural failure progressively, if unattended to, okay, can lead to collapse. Okay, so that is why you see some structures that are stressed. Once structures are stressed, you see them, they won't be able to, carry that load that they are being subjected to. And you see that structure having problems. All right, so let us always pay attention to details. We shouldn't neglect all of these little things. We should pay attention to every detail as far as construction is concerned, because construction is a very meticulous activity, okay, that needs attention at every stage. Then there is also a situation whereby we leave everything to our steel fitters, to our carpenters, and all of that, our messing guys to carry out. Those guys are working based on their level of knowledge or experience that they have garnered. But you understand that there are certain things that they are not privy to. Okay, they are not privy to. So as the engineer on site, it is your duty now to align their thoughts, their work, okay, towards a particular direction that will bring about the well-being of that structure. So that is why most times it's important to organize toolbox meeting, irrespective of how small your construction site is. Okay, as far as you have few skilled men, unskilled men, few as a workforce, it's important that you organize toolbox meeting on daily basis, because that toolbox meeting will create that awareness on daily basis. It brings about the renewing of their mind, all right, of these workers, these unskilled workers. Toolbox meeting helps to renew their mindset, okay, towards the realization of that work, of that project. Okay, you talk to them on daily basis. You try to educate them, try to enlighten them on some of those areas that they feel that, oh, this is all they know about this. But when you enlighten them, they will know that, okay, there is a step ahead of what they know. All right, because as you're interacting on a daily basis in your toolbox meeting, you see them also grow too in their work. Like in construction, we have the steel section, the reinforcement section, we have the carpentry section, we have other sections in the construction setting. All right, so when you now try to enlighten them in these various areas on daily basis, you see that they will achieve that task for that day. There will be no need, there will be no room for carryover. All right, now you see that the lapses, all these construction errors will be curtailed, because they are well informed before carrying out that day's activity. Because once they are informed on what they are expected to do for that particular day, you see that the tendency of having errors, okay, construction errors, will be limited, because they are being informed. Okay, but in a situation whereby you just come to site, everybody, you go to your various and start your work, you see that there will be no coordination. You see there will be a lot of lapses at site. So I want to also use this medium to plead that we also bring in the aspect of having toolbox meeting in our construction site. Okay, that will also help create a room for good relationship between the professionals and the workers, because once there is a good relationship, it also boosts their morals. Okay, it makes them to carry out their works with less supervision. Okay, because once these workers once they have that information, okay, from the beginning, you see that it will require less supervision, because they already know what they are expected to do at every given point in time at site. All right, so let's develop that culture, of having toolbox meeting, in our various sites. That will also improve the efficiency of our workforce. All right. So, like I said, those points I've talked about, those are some of the causes. I talked about improper mixing of concrete as one of the causes of formation of honeycombs, which is the topic of discourse. I talked about improper aggregate grading. I told you that when you don't have a well-graded aggregate, there will be formation of honeycombs, because these aggregates are expected to have a distribution of various sizes that that composes that particular size of aggregate. For example, if you're having a 20 mm size of aggregate, it's expected that the maximum size of aggregate should be 20 mm, but it should also have a mixture of aggregate of 16 mm, okay, below that 20 mm. The sizes that are below that 20 mm should also be constituted in that aggregate. When you have that, it is what we refer to as a well-graded aggregate. Okay, even in sand, we have the fine sand, we have the coarse sand. Okay, the coarse sand is about 4.75 millimeter. That is the size of coarse sand. So a well-graded sand should have a distribution of both the fine and the coarse sand in the mix. Okay, it should have a mixture of this distribution, so that when you do your concrete, you have a quality concrete. Most times our concrete are harsh. We use harsh concrete at site, which is as a result of some of these aspects of our materials that makes up the concrete. So we must pay critical attention to these various materials that we use for our concrete. Okay, so we've talked about congested reinforcement. When you have congestion of formwork as a result of your reinforcement, congestion of reinforcement in your formwork, definitely it will bring about the formation of honeycombs. Now, most times you see that when you have much of reinforcement in your formwork and the spaces are very close, you must adopt size of aggregate that are less than the size of the spacings. Okay, the reason is that when you do your concrete, the concrete can be able to pass through those spaces between the reinforcements. It can pass through, especially your beam. It's expected that the concrete should fill from the bottom to the top. But in most cases, when you use aggregate that are large, that are bigger than the spacings, you see those aggregates, obstructing due to the confinement of the space and also the congestion of the reinforcement. You see that the aggregate tend to act as a blockage for concrete to penetrate. Now, when that happens, you think that your formwork is filled up of concrete, unknowing to you that there are areas that, as a result of the big sizes of coarse aggregate, prevented that place to be filled up. Because, like I said, your filling of your placement of your concrete comes from the bottom. It fills from the bottom to the top. All right. So if peradventure there is an obstruction, it means that it will fill. Once it gets to a certain level, you see those areas there will be voids created. This is as a result of stones that are bigger than the spacings, as a result of the congestion of reinforcement within that formwork. So we must look at that aspect, because that is also what causes the formation of honeycombs in our concrete. So we also talked about faulty formwork. We've talked about faulty formwork. You're welcome. You're welcome. Please, you can drop your questions if there is any. We are discussing how to, prevent formation of honeycombs in our concrete. So we've talked about faulty formworks. All right, your formwork ought not to, have leakages. There shouldn't be openings that will encourage leakages, because once there are leakages during placement of concrete, you see that the concrete, the water that is expected to cause the fluidity of that concrete, okay, will tend to exit through those openings, okay, to exit through those openings. And once it exits the formwork, definitely it will bring about formation of honeycomb. It will bring about formation of honeycomb. All right, now when you try to fill up those spaces, it will not have that original strength of concrete. Okay, it will not have that original strength of concrete, because if there are situations whereby water gets to that point, you see that water can penetrate through those filled materials. Okay, it can penetrate through those filled material than the concrete part of that element, that structural element. All right, so we should try as much as possible to look at faulty or bad formworks at site. We must inspect our formworks thoroughly before concreting operation can commence. Immediately after the carpenter have finished his work, it's important you do you do inspection, do checks of those joints, those lappings, the bracings, and all of that, to ensure that they are tight enough, that will prevent those exits of water. Although there could be seepage, the water can seep. All right, the water can seep, but it shouldn't seep with the cement paste. All right, it shouldn't exit with the cement paste, because it is that cement paste that creates that plasticity, that rheoplastic nature that the concrete ought to maintain at that stage. Okay, that green stage. Okay, the green stage, I mean, at that plastic stage that it can be walked upon. All right, it is that once the water leaves in the form of that cement paste, automatically it's dislodging the cement that is expected to bring about that bonding effect, within the concrete exiting. So we try as much as possible to seal up all spaces, look at the joints, and ensure that they are tight enough, okay, to prevent the exit of water, because that water is needed for the hydration of that concrete. All right, so we have to take note of that. Poor or bad formwork can also result to formation of honeycomb. I also talked about when you have inadequate compaction and vibration. Okay, these are two vital operations that we carry out, in our concrete. All right, vibration and compaction are very essential, when it has to do with concrete works. Okay, we must administer them in their respective areas properly. All right, we should give adequate compaction, adequate vibration of our concrete. That will help to densify our concrete and also close up all the pore spaces, all the pore voids within our concrete mass. So it is very, very important. A situation whereby we have inadequate of those compaction and vibration, it can lead to the formation of honeycomb. Then I also talked about poor workability of concrete. Poor workability of concrete. Now, poor workability here, I said earlier, workability is basically the ease at which concrete can be worked upon. Now, when you have a stiff concrete, it means that the workability is extremely low. It means that the workability of that concrete is extremely low. And when you place such concrete, definitely there will be formation of honeycombs. I gave an example in the case of columns, okay, vertical component. When you use such a stiff concrete, to pour into our formwork for our columns, you see that even the extent of vibration you give to that column, there will be still formation of honeycomb, okay, due to that low workability, okay, because the workability now is a function of being homogeneous, okay. The homogeneity of our concrete is dependent on the workability as well as the strength of that concrete. All right, so we must ensure that we maintain good workability of concrete so that we can be able to prevent the formation of honeycomb. Then I also talked about the improper placement of concrete. Okay, when you don't place our concrete rightly, all right, it will lead to formation of honeycombs in our concrete. So we must endeavor to place our concrete rightly. All right, so these are some of the causes, okay, of formation of honeycombs in our concrete. So we shouldn't neglect we should have all of these in mind when we are dealing with concrete operations, so that we can be able to avoid the formation of honeycombs. All right, so in the next session that will be coming up, I'll be discussing on how we can prevent, how we can further practice that will help us to prevent totally, probably not really totally, but if we do it rightly, we can curtail it to the barest minimum. Okay, we'll discuss that in the next session. All right, so I appreciate every one of you that has been online all through. Thank you so much. I'm going to stop here. Please stick continually to Bengineer Construction Lecture Hall. Updates will be coming as time goes on. Thank you so much. I will see you in the next live session. Thank you so much, and do have a pleasant night rest. Thank you. God bless you. Bye.